Vertical ventilation is frequently the most effective method of ventilation. Today, more emphasis is being placed on vertical ventilation training. Successful vertical ventilation operations require firefighters to be familiar with roof construction, equipped with the proper tools, and properly trained in vertical ventilation methods. Before beginning vertical ventilation, a firefighter must be aware of the many types of roof systems. Typical roof systems are constructed by conventional or lightweight methods. This is an example of a residential roof using conventional construction. Rafters are commonly 2 by 6 or larger. Roofs of this type built before 1960 usually have 1 by 6 decking. Lightweight roof construction uses less material, allows a greater span, and provides a lower building cost. However, during fire involvement, it also shortens the burn time. The hazard of a roof collapse is increased with a reduction of mass and burn time. This is an example of a typical lightweight truss system used in residential construction. This truss system has a 2 by 6 top cord with 2 by 4 webbing held together by metal gusset plates. The roof decking is normally a half-inch plywood sheeting. This is an example of a commercial roof using conventional construction. This type of roof uses structural members that depend on size for strength. The additional mass allows more burn time before the roof becomes unsafe for vertical ventilation operations. This type of construction is most often found in pre-1960 buildings. Today, lightweight truss roof systems are predominant in commercial construction. The lightweight truss used in commercial roof construction is different from a conventional rafter due to the reduced mass and the greater span of the truss. The main components of a truss are the top cord, the web system, and the bottom cord. This system may incorporate a type of open webbing between the top and bottom cords. Here is an example of the metal gusset plate truss. This truss consists of open webbing that connects a top and bottom cord. During a fire, a metal gusset plate may become loose and allow the truss to fail. If one truss component fails, other parts or the entire truss may fail. Another example of an open web system is the steel tubular web truss. The top and bottom cords can be single or double 2 by 3, 2 by 4, or 2 by 6 members. Steel tubing connects the top and bottom cords. In this truss system, the bearing component is typically at the end of the top cord. The wooden I-beam is another type of lightweight truss. Typically, the top and bottom cords are made of 2 by 3 material, resembles plywood laminations, and are glued to a 3/8-inch plywood web. Larger commercial roofs frequently used a panelized style of construction. Laminated beams are used to span the length or width of the building. The purlin, a supporting member, is attached between the beams with metal hangers placed every 8 feet. The purlins may consist of conventional type members or lightweight trusses. 2 by 4 joists are then attached on 2-foot centers between the purlins. Typically, half-inch plywood is provided as decking for this roof system. Before beginning vertical ventilation, firefighters must be equipped with the proper cutting tools. The cutting tool of choice is the chainsaw. An engine with a minimum displacement of 4 cubic inches is recommended to provide the necessary cutting power. The chainsaw allows good balance and reach during ventilation operations. The saw cutting depth allows it to cut through multiple layers of roofing material. But it is important to have a method of controlling the cutting depth. Here you see the cutting method known as rolling the rafter. In this operation, the saw is held perpendicular to the roof surface. The saw is positioned approximately 6 inches below the roof and moved along until contact is made with a supporting member. The saw is then moved up and over the rafter. After clearing the rafter, the saw is then lowered back down to the previous cutting position. This is a good method of controlling damage to the rafter. However, rafter damage is uncertain and its structural integrity may be compromised. The cutting depth is critical to avoid induced truss failure. Also, when using this method, Electrical wiring and other hidden objects may be cut. These cutting hazards can be minimized by controlling the depth of cut. The KISS 40 adjustable depth gauge, when attached to a chainsaw, is designed to control the depth of cut. Once installed and correctly set, the possibility of damaging supporting members and cutting hidden objects is no longer a concern. A fire department style carbide chain is another important component of the chainsaw used for ventilation. A carbide cutting chain will best withstand abrasive conditions and allow the greatest cutting speed. A chainsaw equipped with a 4 cubic inch or greater engine, the KISS 40 adjustable depth gauge, and a carbide chain becomes the ultimate in ventilation saw technology and safety. Now that we've identified some common types of roof systems and components of the ventilation saw, let's examine the vertical ventilation operation. Firefighters, who are assigned to open a roof, should have a plan before they begin. This operation requires training, knowledge, and teamwork to be safe and efficient. The following scenario is an example of a method that may be used to safely perform vertical ventilation on a typical residential roof. First, choose a safe location to ascend to the roof, away from the fire area and exterior openings of the building. Next, sound the roof for stability before stepping onto it. Walk above the outside wall as you continue to sound the roof while advancing to the ventilation site. Use indicator holes to assist in determining the location and extent of the fire. Choose a location that is away from the path that firefighters will use. Make 3 cuts forming a triangle. This enables you to examine fire conditions, the roof structure and thickness, and to set your saw depth gauge accordingly. Proceed to the opening site. Sound the area for stability and to locate a rafter. After the rafter has been located, make the first cut. Begin next to the rafter and cut approximately 4 feet. Next, make a corner cut and then 2 sides parallel to the rafters. Cut the 4th side to complete the opening. Remember, all cuts should overlap at the corners. The roof opening can now be louvered. This procedure is called the center rafter method. Push down the interior ceiling if the main body of the fire is below ceiling level. When the ventilation operation is complete, exit the roof using an established safe route. By comparison, vertical ventilation of a large commercial roof requires a greater commitment of manpower and resources if it is to be accomplished in a safe and efficient manner. The untrained ventilation team can be overwhelmed by the hazards and the challenge of opening a roof for vertical ventilation. Fire location, roof involvement, roof integrity, and dead loads are hazards that must be considered during ventilation size-up. After addressing these hazards, the roof operation can begin. First, determine the ladder location and climb to the roof. Sound the roof for stability. Choose a safe position to begin cutting an inspection hole, locating it away from the path that firefighters will use. The first cut of the inspection hole is cut through the roof decking at 45 degrees to any exterior wall. When the saw makes contact with a rafter, roll the rafter and continue the cut for approximately 1 foot. Complete the hole by making 2 small cuts, which will allow the removal of a triangular portion of the decking directly over the rafter. To determine the spacing of the rafters, make a cut perpendicular to the rafters. When the saw encounters the next rafter, stop cutting. This opening can now be used to correctly set your saw depth gauge. A commercial roof with rafters on 2-foot centers may be ventilated using the following method. The roof team will continue to sound for stability as they approach the ventilation site. Additional indicator holes may be cut as needed to determine roof integrity and fire location. The ventilation site should be over an uninvolved area of the roof and as close as possible to the seat of the fire. Using the center rafter method, begin cutting the ventilation opening. Hole size is proportional to building size and fire conditions. When the ventilation operation is complete, exit the roof using an established safe route. A space of 8 feet between support members indicates the presence of purlins and a panelized roof system. The following is one method of cutting a ventilation opening in a panelized roof. Vertical ventilation operations for a panelized roof will require the full cutting depth of the chainsaw. Remove the saw depth gauge at this time. Advance along the roof perimeter toward the ventilation site. Walking on adjacent purlins, proceed toward the ventilation site. Additional indicator holes may be cut as needed to determine roof integrity and fire location. Upon reaching the ventilation site, make a perpendicular cut between the purlins. Next, cut 2 notches for the rubbish hooks. Cut the sides of the opening 6 inches away from the purlins, with the saw cutting deep enough to cut through the deck and the 2x4s. At the same time, use the rubbish hooks to hold the roof panel. After cutting 4 feet, the panel can be pulled back. The cut panel can now be pushed aside. The opening can be enlarged by repeating this procedure. When the ventilation operation is complete, exit the roof using the same established safe route. Remember, when operating on a panelized roof system, the safest path is on the purlin over an uninvolved area of the building. Ventilation is an important tactical tool used to control fire conditions. Vertical ventilation is frequently the most effective method of ventilation. Firefighters who are familiar with roof construction, equipped with the proper tools, and trained in correct vertical ventilation methods, will contribute to the overall success of fire ground operations. The purpose of this video is to aid in developing safe and efficient vertical ventilation operations in your fire department. There are publications, videos, and specialized training consultants that can provide additional information about vertical ventilation methods and techniques.